This is the chemistry lecture for the first part of the predicting products of a reaction series of lectures. Today we're going to be focusing on the first three kinds of reactions: synthesis, decomposition, and combustion reactions. So to start, we have our synthesis reactions. We can recognize a synthesis because it is an element plus an element. So element plus element makes a single compound. In other words, element A plus element B makes compound AB. So if I had calcium plus sulfur, I'm going to make a single compound. You're going to have to use your nomenclature rules. That compound is going to be calcium sulfide. Remember, we always name our metals first and then the nonmetal. You can also do this from a formula if you know that you have calcium plus sulfur. Well, right now, as elements, these things don't have charges. But once they become part of a compound, they gain their charges. We know calcium is in group 2, so it's +2. We know that sulfur is in group 16, so it has a -2 charge, which gives us our formula, CaS. So if we have something that's predictable, then we easily know its charges because it's predictable. It's the whole point, right? Group 1 is +1, group 2 is +2. Cadmium, cadmium, and zinc are +2. Silver is +1, and aluminum is +3. Remember, all your nonmetals are also predictable. However, we will have you deal with some metals that are not predictable. If you must decide what the charge of a non-predictable metal is, on the back of your periodic table, you'll see a chart that looks like this guy right here. Now, here, you'll notice that nothing is circled. On the back of your periodic table, they are circled for you. These are the two most common charges for unpredictable metals, but we're going to let you just go ahead and assume that the one that is circled on the periodic table that you have access to in the classroom or in Google Classroom, the one that is circled is the charge that you are going to assume that that metal has. Normally it's unpredictable. This is kind of like just saying our best guess is it's probably going to be one of these charges. So, for example, cobalt is normally unpredictable, but if you have to try to guess what its charge is going to be, you'll use the +2 because that's what's circled on the back of your periodic table. So let's do a couple quick examples. If I have iron plus chlorine, Fe plus Cl2, because remember that chlorine is a diatomic, I'm going to make a compound out of those two things. Well, iron is normally unpredictable. It's a transition metal, but I can look at the chart right above me and see that it's probably going to be a +3 charge. It doesn't have to be a +3 charge, but that's the best guess that we can give it because it's unpredictable. Chlorine, on the other hand, is a -1 charge because it's in group 17. It is predictably -1, which gives us our formula, FeCl3. To finish off the word equation, we name the compound iron 3 chloride. Let's do another one. Magnesium plus iodine. Same idea. We got magnesium, and we know that since magnesium is in group 2, it's going to be a +2 charge. Iodine, same as chlorine, is in group 17, has a -1 charge. So we get our compound MgI2. To finish off the word equation, you now got to name it, magnesium iodide. I did forget, before we move on, you do have to balance your equations. So the one we just did, magnesium plus iodine, that conveniently comes balanced. However, the first one, iron plus chlorine, we do need to go back and balance. And now we're good. Last but not least, zinc plus oxygen. Zinc is Zn, oxygen is O2. We know that zinc is +2 because it's part of Cadmium. Oxygen is in group 16, so it's -2. So my compound would be ZnO. To balance it out, we throw a 2 in front of ZnO and a 2 in front of zinc. And to finish the word equation, we name the compound zinc oxide. The second kind of reaction we're going to be looking at today is the decomposition reaction. We talked about this yesterday. We know that we can recognize it because it starts with just a single compound that then splits into its individual elements. Decomposition tends to be the easiest of the 5 to predict. It's between this and the combustion reaction, which we'll talk about in a second. But we know that if I start with compound AB, it splits into element A and element B. So if I have magnesium sulfide, Mg is +2, sulfur is -2, so I have MgS. I know that that's going to split into its individual elements, magnesium and sulfur. In order to do a decomposition, you basically input a bunch of energy that causes the chemical bonds to separate and the compound to decompose into its individual elements. So here's water, H2O. Well, we know the 2 parts of H2O are going to be H2, and it's always really tempting to just write O. But you got to remember that O is a diatomic when it's by itself, so it's actually going to be O2, for the same reason that H2 is a diatomic. So we have our decomposition reaction finished. We've got to balance it out, 2 there, and then we finish the word equation, hydrogen plus oxygen. Next up is lithium nitride. We know that Li is +1 because it's in group 1. Nitrogen is -3, so my compound would be Li3N. Well, that's going to decompose into lithium plus nitrogen, but you got to, again, remember that nitrogen is a diatomic. So I throw a 2 in front of Li3N to give me 2 N's, and a 6 in front of Li to give me my 6 Li's. And I finish my word equation, lithium plus nitrogen. Last but not least, I have copper 1 oxide. So copper would be +1, oxygen has a -2 charge. That's going to split apart into copper plus oxygen, another diatomic. To balance that out, I'm going to have 2 Cu2Os to give me my 2 oxygens, 4 coppers, and I finish the word equation, copper plus oxygen. Now notice that in the compound, these things all have charges. But as elements, they do not have any charges. So for copper, you have copper 1 while it's in the compound, but once it's a free element, there is no charge written next to your copper. Finally, for today, we have the third reaction, and that's going to be a combustion. Now, remember, we talked about this yesterday. Combustion tends to always follow the same pattern. You have a hydrocarbon plus oxygen. That's how you recognize it. But it will also always make the same 2 products, water and carbon dioxide. We always know that if you are going to say that a reaction is a combustion, the products must be H2O and CO2 every single time. So if I look at this example, I have ethane, and the formula for ethane is right there, plus oxygen. Well, that's a hydrocarbon plus oxygen. I know my products must be water and carbon dioxide. I don't have to think about it too much. You just got to build the habit of, as soon as you know that you have a combustion, you know you make water and carbon dioxide. So, a couple examples here. Propane plus oxygen. Hey, that's a combustion. I got the hydrocarbon plus oxygen. I already know right off the bat I'm going to make water and carbon dioxide. If you want to get a balanced chemical equation, I know that I'm going to make H2O plus CO2. I'm going to need 3 CO2s and 4 O's to get my C's and H's balanced. That gives me a total of 10 O's on the right, which means I need 5 O2s on the left. Last example here is octane plus oxygen. Again, right away, you know that you have a hydrocarbon plus oxygen, so you can already tell me your products, even without writing the entire chemical equation, are going to be water and carbon dioxide. However, if you do want that balanced chemical equation, it's a simple enough process. You know you're going to make H2O plus CO2. I'm going to need 8 CO2s, 9 O's, which gives me a total of 25 O's, 16 from CO2, 9 from H2O, which means 12 and a half O2s. But I can't leave it like that because it's a decimal, so I'm going to go through and double everything. And I'm going to get some really, really big coefficients, but that is okay because it's still balanced. All right, here's your practice for the first day of reaction prediction. You have about 12 questions here. Notice you have to be able to type the type of reaction in order to predict what you make. So you always start there. Step 1 is always identify, then you finish the word equation as needed. But please make sure you finish those word equations.